All right, Matthew. I'm gonna make this video on a plan day on Wednesday, so you guys can get started on Module 2. The Monday, Tuesday in class people, they've already went over this, but for you virtual kids and the ones who have not been in class yet, this will give you a head start. So the next unit is going to be all about quadratics, graphing them, solving, and all that stuff. So I want to go over some of the stuff with you that goes along with it. Now, a lot of this is going to be done on Desmos. Once I show you how to do it by hand, then we'll do it with Desmos, and then that way you guys, it'll make it easier once you do it on Desmos. Okay. So first of all, let's talk about quadratic properties. Sorry about that, y'all. So let's talk about quadratic properties first. Okay. All right. So let's get very, very basic first. Okay. A quadratic function makes a graph that is called a parabola. So, guys, some of this stuff is review. With the school year getting cut short last year, some of this stuff you may have been in the middle of it when all this was, when all that stuff went down. So let's. So first of all, it makes a parabola. A parabola either opens up this way, or it can open down. Makes a U shape. Okay. All right. The lowest the lowest point or the highest point, whether it opens up or down, this is called your vertex. Okay, either one of these could be vertex. It's always the highest or lowest point. Okay, I will talk about more about vertex in a minute, how to find it and things like that. Okay, now the parent function. This is very important for this unit. The parent function of a quadratic is y equals x squared. That's the parent function. Okay. Now, what it means to be a parent function, if something is a parent function, it means it has no transformations. It's not moved. Okay. It's not moved left, right, up, or down. Okay. It's not reflected down or anything like that. Okay. So basically, it has no movement from the origin. All right, so let's talk about the parent function for a minute. Okay. Now, if you've got a coordinate plane, guys, I'm gonna try to draw this the best I can. As long as we get the basics of it, you should be good. So we got this is the x-axis, this is the y-axis. Now, a parent function, y equals x squared. Okay. It has a vertex at the origin, which is 0, 0. That's called the origin, 0, 0, same thing. Okay. Now, the parent function opens up, okay, like this. Makes that parabola shape. That's a parabola, okay. Makes the parabola shape, has a vertex of 0, 0. Notice it does have arrows on the ends. If it has arrows on the end like that, that means it goes on forever. It does go to positive infinity. Okay, it does go to positive infinity. All right. It also goes to negative infinity in the negative x direction, and it also goes to positive infinity in the positive x direction. Okay. That'll come in handy in the domain and the range. Okay. All right, so the parent function of a quadratic is y equals x squared. That means it has no transformations. Okay, that means it's not been moved from left to right. Okay, it's not been reflected down. Okay, so that being said, that's what the parent function is. The parent function has a vertex or lowest point at the origin 0, 0. Okay, now let's keep going. Now, let's talk about standard form of a quadratic. Guys, very important concept here. Standard form. Standard form. If I ask you what's standard form of a quadratic, that is y equals ax squared plus bx plus c. Okay, that's standard form. Or you may see it like this: ax squared plus bx plus c equals 0. If you're solving for x-intercepts, it's going to be set equal to 0. If you're graphing, it's going to be y equals ax squared plus bx plus c. Okay? Now, the ax squared term is called what I'll refer to as your quadratic term. So it's your quadratic term. So guys, if I refer to on a video or in classes, what's the quadratic term, then you'll know what that is. The bx term, that is called, I'll refer to it as the linear term. Okay? All right. And then your C term is what I will refer to as your constant term. Or constant. Constant or constant term, same thing. Just remember, very important, standard form is ax squared plus bx plus c. Ax squared is a quadratic term, bx is a linear term, c is your constant term. Okay? Same thing here, doesn't matter what it's equal to. Quadratic, linear, constant. Okay? So that's that basic stuff there. All right. All right. So let's talk about some more properties of a quadratic. All right. Going back to ax squared plus bx plus c. We'll just do 0. Okay. Now let's talk about how to get the vertex. The vertex. All right. To find the vertex, first of all, you got to find the x value of the vertex. All right. To find the x value of the vertex, it's x equals the opposite of b over 2 times a. That is the formula to find the x value of the vertex. Okay. Notice it's not the y value of the vertex; it's the x value of the vertex. Okay. Now, once you get that, to find the y, okay, what it becomes is this. Whatever you get, and guys, this is a form. Now that's the formula, but it's going to be a number here. You plug it back in. And guys, remember, this is just a number representing what you get after you plug this, put all your A's and B's in here. That will give you the y value of vertex. All right. Now, so to get the x value of the vertex, okay, that's the formula. Okay, to get the y value of the vertex, you take the number. Now, guys, when you plug this in, you'll get a number. It'll be a number. You'll see it in just a minute. And then to get the y value of the vertex, you plug that number in, which is represented by this, and then you just get the y value of the vertex. Also, this formula also gives the axis of symmetry. refer to as the AOS. You'll see me refer to it as the AOS. And usually in your direction it'll say AOS. That's the abbreviation for the axis of symmetry, or the acronym for axis of symmetry. All right. So this formula gives you the axis of symmetry and the x value of the vertex. Okay, so that gives you two things. This thing gives you two things. All right. Now, so we'll talk more about that. This is your vertex. So this is all vertex stuff. How to get the vertex. All right, that's all this stuff right here. Now, guys, that's by hand. Okay, so I'll show you how to do it by hand, and then we'll do it with Desmos. Okay, so much easier on Desmos. Okay. Now let's talk about something real simple. Let's talk about the y-intercept. Now, the y-intercept is always the x value of your y-intercept. Now, guys, listen to this. The x value of the y-intercept is always 0. Okay, it's 0 and your constant term. Guys, remember, going back to constant term, your constant term is your c value. Okay, the c value constant term is exactly the same thing. Okay, all right. And the reason x is 0 because at the y-axis, y-intercept work across the y-axis, same thing. The x value is always 0. Okay, so it's always 0 in your constant term. Okay, and the reason it works like that, because if you do y equals and you plug in 0 everywhere you have an x, what happens is the linear term and your quadratic term will cancel out, and then you get y equals c, and then that's the y-intercept. Okay, so that's how you get your y-intercept. Okay. All right. So let's talk about. Let's see. All right, guys. Sorry about that. All right. So the y value, the y-intercept is your 0 in your constant term. Okay. Now let's talk about domain first. Okay. All right. Domain's very easy with quadratics. Okay. Now in math 2, you will study quadratic square root functions, stuff like that. Now, if you, at the beginning of the video, we talked about the parent function. Okay. Now, this is parent function. Vertex is 0, 0. Okay. Now, remember I said that if you have a parabola, it should have arrows on the end like that. Arrows means it goes on forever to positive infinity. Okay. Now remember also what it does. If it keeps going, this thing's going in like a northwest direction and a northeast direction. Okay. So that being said, it is going east to west. And if you think about it, guys, your your x-axis is west and east. Okay. So if it keeps going to positive infinity, it's going to eventually cover all your x values too. Okay, east and west. Right. So what this does, it covers all x values to negative infinity, and it covers all your x values to positive infinity. And the reason why, because it keeps going forever and ever. As this thing keeps going, it goes and it keeps going in that northwest and northeast direction. It's going to cover all your x values as it goes in the east and west direction. That same being said, any parabola or any quadratic function that is not what we call restricted, but you won't do that in math 2. Any quadratic function that is not restricted, and guys, like I said, you will not do that in math 2, has a domain of all real numbers. And guys, remember, when we're talking about domain, remember domain from math 1 is simply just the x values. It's simply just the x values of a function. Okay, it's just the x values. All right, so if I say domain, all I'm talking about is your x values of your function. These are the x values on the x-axis. This is the domain of a function, the x values of a function. Okay, and like I said, any quadratic function that is not restricted, which in this case they will not be, has a domain of all real numbers. Also, you may see it in what they call interval notation, which is negative infinity to positive infinity. Okay. You may also see it this way. All real numbers, you may see it all spelled out as all real numbers, or it may be like this. It has 2 lines and it makes an R. That is also all real numbers. Okay. I've seen it all these different ways, so just keep that in mind. Probably for your sake, it's going to be all real numbers like this. It's going to be spelled out for you. Okay. All right. Now, so we talked about domain. And guys, remember, any quadratic function that is not restricted has a domain of all real numbers. Okay, it covers all your x values. All right, so keep that in mind. All right, let's talk about range. Now, range is a little different. Range is a little different. Now, let's go back to the parent function again. Now, guys, remember, the reason I'm going back to the parent function because it's very easy to see, but it could be any parabola, any quadratic function. Okay. Now, remember, all throughout this video, I talked about how it goes to positive infinity. Now, your range is simply the y values of your function. Okay, it's just the y values of your function. All right, now, the y values are on the y-axis, which is north to south, right? Now, if this thing goes to positive infinity, right, and say, for instance, and remember this is the parent function y equals x squared, okay, your vertex is 0, 0, okay? Now, if we're talking about the y values, all you care about is this number right here. That's all you care about as far as the range goes, okay? So now think about it. If 0 is its lowest, if 0, 0 is its lowest point, okay? If 0, 0 is its lowest point, then it's not going to cover anything down here, okay? So you know that it's not going to be any values down here. So you know it's going to stop at this, the y value vertex, okay? So now, the range can be written like this. Y values, this is called set builder notation. Y values when y values. Now, guys, think about it. As I go up on the y-axis, the y values get larger. All right, so if a parabola opens up like this one does, it's going to be y values greater than equal to the y value of the vertex. Okay, now it's the y values when y values are greater than equal to the y value of the vertex. Well, in this case, this is going to be y values when y values are greater than equal to 0, because your y value of your vertex is 0. Okay, that's why this number is 0. Because guys, remember, your range is always going to be y values when y values are greater than equal to the y value of the vertex. Okay, now, what if we have one? Now, the domain, it doesn't matter if it opens up or down, but the range it does. Okay, say we have the parent function that is actually reflected down, which that would not be a parent function because when it's reflected down, that's a transformation. This is y equals negative x squared. Only thing different, this negative out here makes it reflect down. Okay, now Vertex is still 0, 0, but this is a maximum point or the highest point of your function. Okay. So now, if it goes down, if it if it if it opens down, the range will be y values when y values are less than equal to the y value of the vertex. Okay. Um, in this case, the y value 0 opens down. Okay. Okay. So when it opens down, that's when it's turned this way. Only thing changes is the direction of your inequality. If it opens down, it's turned this way. If it opens up, see, this is up, this is down, right? Which way the mouth is opening. The only thing that's going to change is the direction of your inequality. Okay? This is greater than, this is less than. All right? Now, you may also see it like this. In this case, just y values. Well, let's do the set builder first. So y values, when y values are less than equal to 0, that would be the range for this function. And the reason why, y value 0, okay, of the vertex. All right. Oh yeah, you may also see it this way, just y values less than equal to 0. You may see it that way on a test. Or it may be this. It could be, well, it won't be in, we're not going to go in interval notation because you won't see that anyway. So just remember, guys, that's range. Guys, ranges usually gives students the hardest time with when it comes to finding properties of different functions. But it's very simple. If you could ever, if once it clicks, it's really simple. But if you have trouble with it, just let me know. Okay. All right. Now, let's talk about intervals of increase and decrease. All right. Now, intervals of increasing and decreasing. Okay. Intervals of increase, decrease. Now, let's start with, we'll go back with the parent function again. Okay. So we're going here, here. All right. Now, so parent function, guys, remember, parent function is y equals x squared. Okay. Might be a test question. Very easy if you know what you're doing. Right. Okay. Now intervals of increase, decrease. Now remember when you first started function, linear was the first function that you studied. Okay. Now remember, note, you read a graph, left to right, just like a book. If you got a book and this is the page of a book, you always read it left to right. When you get done, just go to the next line, right? That's how you do it. You always read a graph like you read a book, left to right. Okay. So now, think about this way. If you're on a roller coaster, okay, and you're starting off, the first thing you're going to do is you're going to go downhill, right? You're going to go downhill. If you're going downhill from, because guys, remember, it's left or right. So if it's going downhill, then it's got that negative slope, right? That is a decreasing interval. All right. Then you get to the bottom of that hill and you start going back up the hill. When you go back up the hill, left to right, that is an interval of increase or increasing. Okay. Now, make sure you understand this. Intervals of increase and decrease are always given in respect to the x values. All right, so now what does that mean? Well, if you remember, this is 0, 0. The vertex of the parent function is 0, 0. Okay. Now, so if you think about it, guys, any number left of the y-axis, those x values are going to negative infinity. Okay, it's negative infinity way over here, and it comes down. You count on down until you get to 0, and then you start your positive x values, and it goes to positive infinity. Okay, now, so that being said, if you think about it, if you start the roller coaster way over here, you started at negative infinity. You're starting at negative infinity, you coming this way, and then all of a sudden you're decreasing. So you actually started decreasing when x values were less than equal to 0. That's when you started decreasing. All right, so you started decreasing here, and as soon as you got to the vertex at 0, and you started going back uphill. Okay, so this is your decreasing. Now, if you think about it, guys, you decreased until you got to a value, until you got to your vertex, and then when you got to your vertex, what happened? You started going back uphill. So you started increasing when x values were greater than or equal to x value of the vertex. Now, guys, remember, it's always the intervals of increase and decrease given to respect to the x values. It's always going to have the x value of vertex in your answer. Okay, the x value of the vertex is always going to be in your answer. Okay, always. Now, so that being said, we decreased on this side, on this side of the y-axis, which that's x value is less than 0. Then that's where we got this from. And then we started increasing when if x values were greater than or equal to 0. Okay, so that's your intervals of increase, decrease. Okay, all right. In behavior, guys, we'll do it. We will do it on a graph. Okay. Now, let's do number 1. Okay. Now, the first thing we're going to do is just going to sketch the graph of each function, get the vertex, axis of symmetry, domain, range, intervals, increase, decrease, and in behavior. The only thing we haven't went over so far is in behavior. Okay. So now, let's get the vertex first. Now, if you remember, the vertex, that formula was x equals the opposite of b divided by 2a. All right, now your function is y equals 2x squared plus 16x plus 35. All right, now that's your a, that's your b, that's your c. A, b, and c will always be numbers. Okay, it's not the x squared. This is not your a term. That is your quadratic term, but the a is the number in front of your coefficient. Your b is the coefficient in front of your linear term. Okay. Now, well, my b is 16, so this tells me negative b or opposite of b. So if this is negative, that means opposite. So if it's positive 16, it's going to be negative 16. Okay. If this was negative 16, this would be a positive 16. It's always the opposite sign. All right. And then it's 2 times, the 2's always in your formula, your a value, which is this guy, which is 2. Okay. All right. So now if we get this, that's going to be x equals negative 16. Now 2 times 2 is 4, which is x equals negative 4. Now, what we have here, we got 2 things here. We've got the x value of the vertex and the axis of symmetry. That's 2 things. So actually, guys, you've answered this question and you got a part of this question. Okay. So now, that means that's your AOS, and we got the x value of the vertex. Now, we need the y value. Now remember, what you're going to do, guys, you're going to take this number and you're going to plug it into your function. So it's y equals all right, so I'm going to plug that number in. Everywhere I see an x, I'm going to plug this number in right here. Okay, so that's y equals 2 negative 4 squared plus 16 times negative 4 plus 35. Okay. Now, don't want to do that in our head. We're going to do it with the calculator. Save us some time. All right. So now, what I'm going to do, pull it over here. All right. So that's going to be 2 times -4 squared plus 16 times -4 plus 35. All right. Enter. When I plug this in and I evaluate it in my calculator, I got y equals 3. This is the y value of the vertex. All right. So that number is going to go here. So this is your vertex right here. So your vertex is -4, 3. All right. So what I'll do is go to this graph here actually goes in intervals. Let's see. Yeah. So -4, +3. That's going to be here. That's my vertex. Okay. I know that's my lowest point. The reason I know is because this 2 is positive. Okay. I forgot to talk about that, by the way. All right. So now, oh yeah, another thing, AOS is x. It's got to be x equals. Don't forget the x equals part, guys. Make sure when you give me the axis of symmetry, it is x equals the x value of the vertex. You leave the x off, it's not right. Okay. So now, my axis of symmetry, I'm gonna make it as a dotted line. All right. That is my AOS, which is x equals -4. All right. So there's the axis of symmetry. Now, to get the rest of our points, I'm going to put it in the calculator. We're going to do this all in Desmos next. Okay. So now, we're going to do it in TI right now. So if I put my formula in there to it, my equation, 2x squared plus 16x plus 35, hit graph. All right. Now, if I go to my table, second graph, I'm going to find in my table, I'm going to find my vertex. All right. All right, -4, 3. All right, now what we're going to do, guys, we're going to plot some of these numbers. Okay. So now, when x is -2, it says the y value is 11. When x is -3, y is 5. When x is -2, it's 11. All right. When x is -5, it's +5. And when x is -6, it's +11. Notice it has symmetry. All right. Notice it does have symmetry. Now, what that means is this is a line of symmetry. If I fold that over, if I could draw it straight, if I'd fold it over the axis of symmetry, it would fold onto itself. Okay. And it would fold directly over here. That means it has symmetry. Okay. Now, let's see. The next thing, domain. Now, guys, if you look back at the notes I did, domain is always all real numbers. And if you don't understand why, if you look back in the video, I explain it pretty detailed. But the domain is always all real numbers.